We're still continuing on this concept of trying to figure out what caused the fish kill in Riverwood. All right, so we're going to focus this chapter on the things that could possibly be contaminating water. There's going to be a lot of chemistry that we are going to cover in this chapter. We're going to talk about physical properties, the difference between evaporation and boiling, the importance of physical properties of water, density, what is that? Chemical properties, the types of mixtures, chemical formulas and their symbols, the electrical nature of matter, ions, and finally, by the end of this chapter, we're going to look at how to write ionic compounds. That's pretty exciting. Next Monday, we will do that. All right, so we begin with our notes. I would highly recommend that as you are listening to this lecture, you focus when I switch over to numerical questions, because that is referring to your notes page. All right? Notice there's not a number here. What does that mean?
We don't have to write it down.
You don't have to write it down. This is what I think is important, not necessarily what the state thinks is important. What is the rarest, most unusual substance in the universe? Any guesses?
Yellow.
Jello is mostly this, yes. But water. Water is bizarre, folks. First of all, there's very little of it in the universe. We are living in a watery planet. We hope to one day find a planet out there that's full of water like ours, because then we could eventually colonize it. Okay? Like in Avatar. But for now, there aren't any planets out there that are loaded with water like we are. Yes?
They actually found one that's habitable?
No, it's in the habitable zone. It is the right distance from the right type of star that could have possibly have developed into a planet like ours. Whether it has water in it, we don't know. But it is in that sweet spot, far enough from the sun that it's not going to be too hot, but close enough to the sun that it gets the heat that our sun gives us. So it's in that sweet spot, but it's not necessarily, we don't know whether it has water in it. Water is bizarre, folks. Its boiling point, 100 degrees Celsius, is way too low. Its freezing point, 0 degrees Celsius, is way too high. I know you can't appreciate this because you're not used to other chemicals. But the fact is that water is very strange. Water sticks to itself. We call it surface tension. Unbelievably. So much so that water can be drawn up the sequoia trees up in California. It is amazing. Water is so strange. We live in a watery planet. We are mostly made up of water. In the Star Trek episode Silicon Avatar, which I'm sure you've all seen, remember that crystalline life form, those creatures that were made of crystals? They refer to us as ugly bags of mostly water. Now, I resent the whole ugly part, but what about the bags of mostly water? That's pretty true. Now, even compared to them, they were these beautiful crystals. Compared to them, I guess we could go with the ugly part, but not all of us, right? Kate Upton, is that her name? Is she an ugly bag of mostly water? How about Jacob from Twilight? Is he an ugly bag of mostly water? You're blushing. Oh, you don't like him? This is a bizarre picture right here. Well, actually, you can't see steam. You can see what steam becomes when it cools down. So you're actually seeing the evidence for all three phases of matter. Water's one of the only chemicals known to man that you can see all three phases at one time. Solid, liquid, and you don't see gas, but do you see the evidence of gas?
Yes.
You can't see the
besides water that can do that.
carbon dioxide under an enormous amount of pressure.
That's it?
Well, it's the only one I can think of. I'm sure there's others.
Oh, I'm asking.
How much of the Earth's surface is covered by water?
75%.
70%. Is water ever entirely pure?
No.
No, even in its rainwater form, it's not pure. I have purified distilled water in the lab. Even that is not pure. Because as long as it's exposed to the air, it's not pure. It'll pick up carbon dioxide. So it is very, very, very difficult to encounter pure water. Surface water, of course, is going to have all sorts of stuff dissolved in it. So it's definitely not pure. All right, here we go. First target of the day is I can identify a property as being physical or chemical. Physical or chemical. We're going to use grace as an example. Okay?
Oh, yay.
We can determine Grace's height. How tall are you, Grace? 5'4", maybe, which means she could be 5'3" or 5'5". We're not sure. She's not sure. She has brown eyes. Now that you know she's 5'4", will that tell you what will happen if Jacob from Twilight comes and asks her out? No. But she's 5'4". Doesn't that help? No. Okay. What if I was to tell you she has brown eyes? Will that help you determine how she's going to react if Jacob comes and says, "Hubba bubba, go out with me. We'll go bowling. We'll go to Hardee's."
They might roll into the back of her head.
Okay. What if I was to tell you she has black hair?
That means nothing to me.
Okay. Brown
That's
skin.
talking to you.
She has brown skin. Will that help you? Oh my goodness, I'm giving you all these great characteristics. She has a mass of 100 pounds. Does that help you now? Okay. I once saw her flirting with this guy that looked a lot like Jacob. Wasn't Jacob, looked a lot like Jacob. And then I saw them at the bowling alley bowling together and hugging each other and acting rather flirtatious. Would that help you? Aha! So now we have seen the difference between physical properties and chemical properties. Physical properties are those characteristics shared by all samples of a substance without changing that substance. They're things that we can measure about Gracie that can help us to define her but not describe how she's going to act. We can say that Gracie has black hair. She has brown skin. She has brown eyes. She weighs 100 pounds. She is 5'4", maybe. How about this? She's wearing a white jacket in the middle of summer.
That might mean she likes the color white.
Okay, that really doesn't help us with Jacob, does it?
Well, if he's white, it might help a little bit.
Oh, so she is trying to tell us that she likes guys with pasty white skin by wearing a
She
white
might
jacket.
Like Edward instead.
She might like Edward instead.
Or she likes warmth, and then she would go with Jacob because jacket and warmth. And
Oh, you're
He's
saying
warm.
Jacob is a warmer kind of guy?
he is. If you see it in the movie,
Edward's like
he's
frozen.
if you see it in the movie, he warms up Bella in like 5 seconds when it's freezing cold and she's gonna die.
I have never seen the movie.
I've seen all of them.
All right, some examples of physical properties. Sulfur is yellow. Does that help you determine how it's going to act with oxygen?
Yes.
No, it's just yellow. How about malachite? Ooh, I'd love to have skin color that color. Malachite green. Wouldn't that be
That
cool?
would be awesome.
I'd be an Orion. An
I think
Orion.
everybody would think we were quite weird though.
Okay. And everyone doesn't think that I'm quite weird?
You're right, actually.
How about if you had color like this? Sapphire. Ooh, wait a minute. What was her name? Karen Gillan in Guardians of the Galaxy had color, skin color like that, right? What was her name? She was, I don't remember. You know who I'm talking about? The bald girl. Nebula. Was it Nebula? Nebula. How about, this is bromine, all three phases of matter for bromine. This is solid. Kind of looks like dog poop a little bit, but this is liquid bromine, and this is gaseous bromine. Really, the only difference between them is how much heat they have. Is it a physical or chemical property that it turns from gas to liquid? It's just physical. Does it change? Does bromine become anything other than bromine? No. So if it stays bromine, it's just referring to a physical property. Gas, liquid, or solid. How about taste? Jeffrey, taste her. See what her taste is. So maybe that can help us. Okay, maybe not. By tasting Grace, will we know how she's going to respond when Jacob is in town? No. How about odor? Sniffer. Somebody sniff Gracie. Will that help us? No. Physical property. Malleability. What if she was to be hit with a hammer and she would to flatten out? Would that help us?
No.
No. Doggone it. How about if we were to determine her volume? Stick her in a big giant pool with increments and determine the difference between the water level before and after she goes in the pool. We now have her volume. Does that help us with Jacob puzzle? How about ductile? Can we drive her through a small hole, have her come out the other side as a wire? Will that help us? No, these are all physical properties. How dense is she? Now, I'm not talking about, how quick on her feet she is mentally. I'm talking about her mass versus her volume. How massive is she in her volume? No. Okay. So, chemical properties refer to, those things that we can notice about her, how she's responding. Okay? If a pasty white guy is flirting with her and she just turns around and leaves, and every time a pasty white guy comes and flirts with her and she turns around, we probably now know that she's not going to like, what's his name? Edward in Divergence? No, Twilight. Edward in Twilight. No, she does not like pasty white guys. But if tan guy, you see her. Okay, so those things about a chemical that we can observe in which they will react with other chemicals to become something new, those are chemical properties. Those are chemical properties. Here are some examples of chemical properties. This is methane reacting with oxygen.
One of the reaction types that you're going to learn about is the combustion reaction. You've probably heard about combustions in automobiles.
They used to do this
Gas
demo,
is
fire
an
marshal.
energy that makes your car go. And your gas furnaces at home actually combust gas to give you heat that heats your homes. Well, today I'm going to demonstrate a combustion reaction right in front of you. Okay, this is called methane bubbles. I'm just generating some methane bubbles right now. So that looks to be enough, so I'm just going to come over here and turn them off. Now when we have a combustion reaction, we have to have what we're going to combust, which is the gas inside these bubbles, and we need an ignition source. So what I have is just a lighter here. I have some methane bubbles. I'm going to ignite them. Okay, so here we go.
It feels warm, that's about it. But you have to be very careful with it. Okay, so what if I was to say that methane will react with oxygen to form carbon dioxide and water? Would that be a physical or chemical property? Chemical property. Very good. This is mercury 2 thiocyanate. Have you ever seen mercury 2 thiocyanate breaking down to become two other things? Oh my goodness, wait till you see this. This is bizarre. It is scary. Some people have cried. Some people have gotten sick. Mercury 2-thiocyanate. In the presence of heat, will break down into different things. No, it'll get amazing. It's not amazing yet.
Kind of awesome.
So, this would be like saying, if you get Gracie mad enough, she becomes 6 foot tall, green, and smashes things. Would that be a chemical or physical property? Chemical. Okay, look at this. Isn't this cool?
Amazing.
That is absolutely awesome. Where did you find this video? I want to show my brother.
Where else would I find it? YouTube.
That's interesting.
I spent all summer looking for cool videos to show you.
I appreciate this video.
Is that a chemical or physical property of mercury 2-thiocyanate? Some other chemical properties would be pH. That's how it reacts with certain chemicals to form acids or bases. Flammability, it's its ability to react with oxygen. Flammability and combustibility are similar. Usually a combustible substance is one that we say maybe does not necessarily become a gas very easily, while a flammable substance is something that becomes a gas very easily. Reactions with acids, reaction with air, those are all examples of chemical properties. Chemical properties. So, in review, if we're looking at a property that just describes a substance without really changing what that substance is, then that's a physical property. If we're looking at a substance, if we were looking at a property that describes how that substance is going to react with another substance, or even with itself to become new things, and the key thing is new things are produced, those are chemical properties. Chemical properties. So what are the physical properties of water? Odorless, colorless, tasteless. But wait! Water does have a taste. Does it, Randy?
The stuff in the water has a taste.
What, Randy?
Yeah.
Why does water have a taste if we say that it's tasteless? What he said. Because there's different stuff in the water that gives it taste. Actually, knowing the way we are, when we do taste distilled water, we say it has a bad taste, right? Why?
They don't taste like
Because it now is tasteless, and we like taste with our water. All right, so we are done with this section. So I want you in the next few minutes to do questions 1A through J in the worksheet. That is section 1.2, question number 1.
the worksheet, the homework worksheet.
The homework worksheet.